Hi class, we are now on 6.3 reactions between metals and nonmetals. So we are looking at a metal plus a nonmetal, and this creates an ionic compound because there's a transfer of electrons from the metal to the nonmetal. So let me go over something that we've already covered. Metals give away the electrons, they lose their electrons, and nonmetals take those electrons, they gain the electrons. When a metal loses an electron, it becomes positive because you have more protons than you have electrons. A nonmetal has more electrons than protons when it gains extra electrons to fill an octet. Those charges, they call electrostatic attraction, create an ionic compound. So what we're going to look at today, and this is going to come up later on in another chapter, and we're not going to cover in depth yet, but I will tell you that this is hard, one of the hardest things for students to understand. So when we get to this chapter later in the semester, this is good to bring it up now so it's not so foreign, but it is sort of difficult to kind of keep understanding what's happening here. So oxidation means loss of electrons. So when a metal loses its electrons, it is oxidized. It is they call it an oxidation state. That's where, if magnesium loses 2 electrons, it now becomes a metal cation. It is an oxidation state. It's lost electrons. When a nonmetal gains electrons, it is gained, so it's been reduced. It's reduction. It doesn't make sense to people because oxidation, we're looking at the charges. So with an oxidation, the oxidation state increases. It can go from a +1 to a +2. It starts at 0 because when it's neutral, it has 0. But with a reduction, which means a gain of electrons, it's being reduced. So for instance, oxygen, let's say oxygen. Oxygen can take 2 electrons, so it's now a 2 negative. It's being reduced from a 0 to a 2 negative. It's been reduced down, where oxidation increases. I know that this is a little hard, so I got some examples. Hopefully this will make sense. We have a whole chapter on this at the end of the semester. Okay, so let me start again here. So in this lesson and those that follow, we're going to explore different types of chemical reactions, which we've already started looking at. We begin with one of the most common types of synthesis reactions. That's the combination of a metal and a nonmetal. So remember, we have A plus B equals AB. Metals and nonmetals react to form ionic compounds. Many of these reactions are intense and they produce bright flames and tremendous heat. In these reactions, the metal loses electrons to form a positively charged ion, which is a cation, while the nonmetal gains electrons to form a negatively charged anion. The result is an ionic compound. The reactions of metals and nonmetals are example of an oxidation reduction reaction. And we call this short term, and I should have wrote it on here, it's redox, R-E-D-O-X, redox. And that's just abbreviation for oxidation and reduction. So when an atom is oxidized, it loses electrons. When an atom is reduced, it gains electrons. So basically what this is, we follow the electrons and where the electrons go. Okay, so let's look at this example here. We have, this type of reaction. So remember, we're looking at a synthesis reaction where they join together. We'll begin this with the reaction of elemental calcium, which is a solid, with sulfur to form calcium sulfide. Let's look at this change using Lewis symbols. In this reaction, the calcium atom loses 2 electrons to form Ca2+, so it's now an ionic form, while the sulfur gains 2 electrons to form the sulfide ion of S2-. The calcium has been oxidized while the sulfur has been reduced. So in this case, this is where you follow through a chemical reaction, and we don't always use Lewis structures. So this is where you got to kind of understand what you're looking at. And if you have to, on the side or above, write what the ionic form would be. So you would get this, and you would have to visually write it out. So sometimes writing above it, what I would do is write a 2+ and a 2-. And from there, you can see like, okay, this is a 0 because it's in solid form. This is a 0. But this one goes from 0 to a 2+. This one goes from a 0 to a 2-. So you see where the electrons actually went. I know what I'm saying is a little difficult to understand. This is one of the hardest sections for students, even myself as a student, to understand. And it takes a lot of just going over the terminology. So once you understand the terminology and you understand the definition of that terminology, then you can start applying it to chemical reactions. And when you understand the definition, it starts making more sense. But that, you have to put an effort into understanding it. It's repetitive. So calcium loses 2 electrons and sulfur gains those 2 electrons. So this is where we look at where they are going. And when we use the term elemental, so in this case it's a solid. So this is a 0 state. It's neutral. This is a 0 state. It's neutral. There's not an unbalanced yet on it. Okay, so let's look at magnesium. Magnesium metal reacts violently with chlorine gas to produce magnesium chloride. Again, let's examine this reaction using Lewis structures. The metal atom magnesium loses 2 electrons, while each chlorine atom gains 1 electron. Why do we need to have 2 of them? Because we have 2 electrons, and chlorine only has 1 spot open for 1 chlorine atom. So we need 2 chlorine atoms. One will take 1 electron from magnesium, and the other will take the other electron from magnesium. So if you can visually, let's pretend this breaks. And what we do is we take 1 here, and we take 1 here. Now remember, this bond needs 2 electrons. So if we break this, we already have 1 electron. It leaves 1 spot open. So we can take that and put that here. If we break this, we have 1 electron, and we take this one and we put it here. Thereby, it fills the octet for each chlorine atom. And this has lost its electrons. This has taken the electrons. That's why we need 2 of them in order to do this. And if you remember, if you can do the crisscross if that helps here. And so this would be a +2, and we need 2 chlorine atoms. So it would be 2 times -1, that equals -2. So 2 minus 2 equals 0. It has to overall be a 0 charge on it. Okay, so the metal atom, magnesium, loses 2 electrons, while each chlorine atom gains 1 electron. So in this reaction, a covalent bond breaks as the ions form. Now, what do you need to know about this section? You need to understand which atom, which element, which one is being oxidized and which one's being reduced. So if you were given this equation and I ask you which one's being oxidized, you're going to have to figure out which one's being oxidized and which one's being reduced. How could you do that? Well, this is what I'm saying. Write the ions on top, and one that's in the positives, and then I shouldn't say positive because that's not always true. But the one that loses the electrons is oxidized, and the one that takes the electrons is reduced. Okay, so how can we predict compounds that will form in metal-nonmetal reactions? So remember from chapter 5 that metals and nonmetals form specific stable ions. That's because of the attraction to the opposite charges. By knowing the charges of the common ions, we can often predict the ionic compounds that result from these reactions. So when we know what the charge is on some of these, we know which ones, basically, we know that these are always going to lose 1 electron. These are always going to lose 2. This will lose 2 or 3. This will lose 2 or 3. And we can follow the electrons and where they're going to go with the nonmetals. So it helps to know what these are, cation, the oxidation states, and what these states are on these when they take the electrons. This will take 3, this will take 2, this will take 1. Okay, so let's look at an example. What compound is formed when aluminum metal reacts with chlorine gas? Write a balanced equation for this reaction. So what this is we know that aluminum forms a 3+. It forms 3+ because it can lose 3 electrons. So it ends up being Al3+. Now it has 3 electrons, but it's being asked to react with chlorine gas. So we need to know one thing. Chlorine gas is diatomic. So we're going to have diatomic, and we're going to have to visually break this. But if that's confusing, just know that 3 electrons, one's going to go with this chlorine, one's going to go with this chlorine, and one's going to go with this chlorine. So when you write this out, aluminum metal, so we're not even looking at physical states here. This is just asking to get started writing these out. So you write aluminum, you write plus, write Cl2, and then what's going to happen? These are going to combine because this is a synthesis reaction. So this is where putting the ion form above it would help. So you could write a +3, you can write a negative and crisscross them. Remember, this is how we're going to crisscross. You now can see with the 3 plus, the aluminum loses the electrons, chlorine takes them. Now what do? You balance it out. You can balance it knowing that you put this compound together, and you can see that with 3, you can write a 3 here. It has a 2, so it's got to be 6. So how would I do this? Okay, take the coefficients off. What I notice here is that I have a 3. So the first thing I'm going to do is write a 3 here. That means that I'm going to have 6 chlorine atoms here. So with that here, a 2 means that I also have to write a 2 here. So 2 aluminum this side, 2 aluminum this side. This is 6 chlorine atoms here. There's 6 here. So it balances out. Okay, so let me go back and see if I can explain. So we write first an unbalanced, I call it a skeleton equation, and then you start putting it together. So aluminum plus chlorine gas reacts to form aluminum chloride. Remember that elemental chlorine is a diatomic gas. So when it says chlorine, you can't just put Cl. It's a diatomic gas, and you are required and responsible to know those 7 that are diatomic. So it doesn't say it in the name. You're just going to have to know that if you're asked for chlorine gas, it's Cl2. If you're asked for oxygen gas, it's O2. If you're asked for hydrogen, it's H2. You will be required to know those. Bromine, iodide, etc. Because if you don't, then the whole thing's off, and you're not talking about something, the equation's not going to balance correctly, and it's going to be wrong. To finish this problem, we balance the equation. We add the coefficients to make sure the number and the type of atom on each side of the equation are the same. So this gives 2 aluminum plus 3 chloride diatomic chlorine, and it produces 2 molecules of aluminum chloride. Now, balancing the equation is not a problem, but if you're being asked which one's reduced and which one's oxidized, you need to know which one they are. And usually just by putting the ions up, this would be 0 because it's a metal, it's a solid. This is diatomic gas in its natural state, it would be a 0. So that means that the transfer of the electrons goes from one to the other. So if you put an ion, you put a plus 3 here and a negative 1 times 3, you can see that the electrons are transferred to the other one. So knowing the definitions again, you can tell which one is oxidized and which one has been reduced. Okay, so we have another example here. Let's look at this one. When tin metal reacts with bromine, it is oxidized to the tin 4 ion, while bromine is reduced to form bromide ions. It's already told you which is oxidized and which is reduced. As long as you know those definitions, that will help you write a balanced equation for this reaction. So now we're at a point where you should be able to pull out these compounds and know how to write them out. Okay, so for the first thing here is that you need to, let's take a look here. The question indicates that tin 4 is formed. We know that each bromide ion has a charge of -1 because it's a halogen. So the neutral compound must have the formula of SnBr4. Why? Because it takes 4 bromine anions with a charge of -1 to cancel this out and make it a 0 charged compound. So as before, we write the equation of tin plus elemental bromine reacts to form tin 4 bromide. To finish the problem, we must balance the equation. So now you just balance it the way that you would. And so in this case, we know that this is an oxidation state of 4. So this is a 4 multiplied by -1. Okay, so we put this down. So you have 1 here, you have diatomic, so you need to know that this is diatomic. So you would normally, let's remove this here. So you have 2. So if we write here, I would write a 2, and then I would write SnBr4 if I have to write it out like this. It is kind of a weird thing. You could separate them too. This is where some of these are a little different because you're actually following the electrons more than what I have shown you in the past. But this is a rather easy one because we still have 1 tin. The only thing is we need to account for 4 bromides. And because of that, this is diatomic, so all we need to do is write a 2, and that will allow this to be balanced out. So just by simply adding that 2, as long as you write this diatomic one correctly, this is actually a rather easy equation to write. I know it may not seem like it at the moment, but it is. And what you need to do is understand what the ions look like, because then you can see which one's been reduced and which one's been oxidized. So that's why these are a little different, because you may be asked that information and you need to know which one it is, because these are where the charges are actually creating an ionic bond because of the transfer of electrons. Okay, so let's go through and take a look at some of the problems here. Show the products from the following metal, non-metal reactions. So I'm going to just give you the answers, and if there's problems with these, we can always go over them. You can also post to Pronto. That way you can get help in understanding how to balance these. And basically the simplest thing here is if I ask anything, it's going to be which one's reduced and which one's oxidized. So as long as you can put what the ionic form of these, you can see where the electrons are being transferred to. When metals and nonmetals react, they form ionic compounds. What type of reaction is? I've already covered this. It's A plus B equals AB. That would be a synthesis reaction, also known as a combination reaction. When heated, iron and sulfur combine to form a new compound, iron sulfide, in this reaction. So this would be one that is a perfect example of a problem. Which one's being oxidized and which one's being reduced? So let me ask you something simple. This is very simple. This might seem like an overwhelming problem, but there's one key thing here. If it's being oxidized and it's being reduced, figure out which one's the metal and which one's the non-metal. And what do those roles have with this? Well, we know that metals lose electrons. We know that non-metals gain electrons. So you may not even have to do the math or follow the ions on this. As long as you know which one, when it's this simple, will help you. So iron is a metal, so iron loses electrons. Sulfur is a non-metal, sulfur gains electrons. But if you wanted to fully understand it, put the charges out there so you can see what happened. So what I did for you on this page, I added this. So if you look at it in ionic form, you see that this is iron 2. Why? Because these are reduced down. Because sulfur is below oxygen and it gives a 2 minus. So here, remember we crisscross them? So in this case, iron has lost the electrons. It's been oxidized is the term. And sulfur has gained those electrons. It's been reduced. So it would be C. What product would form from the reaction of magnesium metal and chlorine gas? So this is asking you to balance an equation. That's what this is asking. You have to put this out. So it would be magnesium plus chlorine gas, which is a diatomic molecule. And then you would put them together. Because remember, this is a synthesis. So these are going to be joined together. So you don't necessarily even have to balance it, but you got to know that these come together and what would that final compound be, even if you don't know the coefficients in front of it. So I actually gave this to you. I put this compound, the equation wasn't there for you. And but I'm giving it to you. Remember, this is a crisscrossing. So there's a 2. So if you write MgCl, there's a 2 that crisscrosses, and that's where you get this from. This is a -1, so by default it's a 1 here. Magnesium chloride, it's going to be D. Which of these shows the correct reaction between lithium metal and oxygen gas? So I didn't do anything on this one because I want you to have a thought process. I'm giving you the answer, and you can figure out which one it is here. So I'm just going to give you the answer, but I'm giving you these slides, so hopefully you do them before you check the answers to see if you're on the right track. So on here is C. This is going to be the right answer on